Welcome to lecture number 9. We are going to study relative frequency histogram in this lecture. Before that, we have studied bar charts for qualitative or categorical data. The frequency histogram or relative frequency histogram is somewhat similar to that, similar to bar chart, but the difference is that frequency histogram or relative histogram is drawn for quantitative data instead of qualitative data. This plot or histogram is used for quantitative data, is plotted for quantitative data, right? Before we and it gives an idea of the distribution or a distribution of the distribution in a given raw data, right? To plot a frequency histogram or a relative frequency histogram, we have these 6 steps. Step number 1 is we have to start with dot plot. We have studied dot plot in lecture P&S9. We studied dot plot. We studied how to draw a dot plot for a given quantitative data in lecture number 7. That's step number 1. Step number 2 is that we have to compute the range. In a given raw data, we have to compute the range by subtracting the minimum value from the maximum value, and then we have to select number of pins between 5 and 12 depending on the size of the data, and then we have to compute bin limits, and then histogram, and then relative frequency histogram. So these are the 6 steps to draw relative frequency histogram given the raw data. For example, this is an example of a raw data given to us, and we are asked to draw a relative frequency histogram out of this stuff. These are the birth weights of newly born children in a hospital, and they are 30. So the size of the data is 30. So these are 30 data points. So starting from step number 1, we have to draw a dot plot. Dot plot is plotted like we draw a horizontal line and we write some numbers to make it a number line from 5 to 10. Why? Because why from 5 to 10? Because the minimum number is 5.6 and the max number is 9.4. So we have to draw numbers from 5 to 10 because all data points are within this range. And then the first data point is 7.2. So this is 7.2. So how is this first point plotted? This is 7, this is 7.2. So we draw this point 7.2. The next is 7.8. We draw this point 7.8. The next is 6.8. Where is 6.8? 6.8, this one. So we draw this point. And when we get another instance 6.8, that is drawn on top of this point, and then on top of this point if we get another instance of 6.8. So we have studied this dot plot in one of our earlier lectures, and this is the starting point to draw relative frequency histogram that we'll study in this lecture. The step number 2 is very simple. We have to find out the max number in the given data and the minimum number. Subtracting those gives us the range. The difference is the range, 3.8. Number of pins is 8. This is an arbitrarily selected number of pins. These are selected. These are not computed depending on the size of data. We have 30 items, so 8 is a reasonable number. And then bin limits. Before we compute bin limits in step number 4, we have to find out interval size, that is the range divided by the number of pins. So it comes out to be approximately 0.5. So the first data bin will start from 5.6 and will go up to 5.6 plus this interval 6.1. The second bin will start from 6.1 and will go up to 6.1 plus 0.5 plus this 0.5. 6.1 plus 0.5 is 6.6. The next will start from 6.6 and will go up to 7.1. So the width of each interval is 0.5. Right. That is the interval size. Once we are finished with bin limits, drawing histogram is easy. We have to identify these we have to identify these bin limits on the same number line we have drawn earlier in step number 1 for the dot plot. And we see the first bin is from 5.6 to 6.1. We see how many points are there in the original dot plot between this interval. So from 5.6 to just 6.1, just before 6.1, we have two data points here, so therefore the height is proportional to 2 for this bin number 1. For bin number 2, from 6.1 to 6.6, these are the limits. Let's see, 6.1 to just 6.6. So these are number 6.6. So this gives us a number, this gives us 2, because there are only 2 data points between these two these two limits. And then from 6.6, and that is we have drawn from for the second bin, the height is 2 because we got only 2 data points in this interval. And then from 6.6 to 7.1, we get 4 data points. From 6.6 to 7.1, from 6.6 to just before 7.1, maybe we get these 4 data points. And then from 7.1 to 7.6, we get 5, 8, then in the next is 8, in the next bin we get 5, then 3, then 1. So this is how we can complete this histogram starting from the dot plot. So I repeat, we started from dot plot, then we computed range, then we selected number of bins, and then bin limits by first computing interval size, and then we have drawn this histogram. And then relative frequency histogram, that is very simple. We have to take this histogram and we have to do nothing new, but we have to just divide each number by the total number of data points we have. How many data points we have in the original raw data? These are, how many data points are there? How many data points are there? There are 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. 6 5s are 30. So we have 30 data points in total. So we'll divide height of each bin by 30. 2 by 30, 2 by 30, 4 by 30, 5 by 30, 8 by 30, 5 by 30, 3 by 30, and then 1 by 30. And one important thing about relative frequency histogram is that if we add heights of all the bins, the sum comes out to be of 1. This is very important, and we'll use this property for probability distributions that we will discuss in next chapters. That's all for this lecture. Maybe there will be 1 or 2 more lectures from this chapter, and we'll study out of those lectures, 1 will be on Minitab, hopefully. That's all. Thank you.